Welcome to the museum, David.
Thank you.
It's September the 9th, 2014. We are here in the Computer History Museum, and I'm David Laws, semiconductor curator here at the museum. And I'm going to interview David Fullagar on life and times in the semiconductor industry. Perhaps we could go right back to the beginning. David, could you tell us where you were born? You can tell us when you were born if you wish, and a little bit about your childhood.
Yes, I was born in 1942 in West Kirby, right outside Liverpool. And my parents lived in Liverpool, although my father was off in the war in the Orkney Islands, but they didn't have maternity wards in Liverpool because of the bombing, so they moved all the pregnant mothers out to West Kirby, and that was 1942.
And you lived in West Kirby through your childhood?
Only until I was about 3 or 4 years old. And then at the end of the war, my parents had dreamed of being in a place which didn't remind them of the bombing and the war and the cities. So they bought a country cottage in Yorkshire, and my father got a job in Yorkshire. And it was a very romantic little cottage on the edge of the moors, but it had no electricity. So in terms of my early electronics career, this is definitely a limitation. So I was somewhat restricted to crystal sets and radios that could be powered by batteries, which were few and far between in those days because of the vacuum tube consumption.
What was the town?
It was, the nearest town was called Baildon, and it's sort of on the edge of Oakley Moor.
Okay. So what kind of school were you able to go to out in that part of Yorkshire?
Oh, initially a little tiny sort of kindergarten school, but then after that I went to what was called in England a preparatory school in Harrogate, and that was as a weekly boarder. You know, the boarding school system in England is fairly prevalent, and there were no really good schools within walking distance of our home because it was a mile to the nearest anything. So I used to get on the bus every Monday morning and go to school and come back on Friday evening.
Did you enjoy school?
Yes, I did, yes.
Any particular subjects that you felt enjoyed most?
You know, I always enjoyed the science subjects, but at preparatory school, prep school, I don't think I really had any preferences other than somewhat dislike of Latin. No.
Not a great disadvantage in the scientific area, but good job you're not a horticulturist.
Well, that's true. Right.
And was there a particular teacher or somebody that steered you in the science direction? There was a teacher called Mr. Plummer that certainly was fairly inspirational, but I think it probably wasn't until I got to high school or public school that I really got deeply into the sciences with a teacher that did inspire me. So that was, 1955 to 1960 was the high school era. Was there anyone in the family that was inclined towards science or engineering that perhaps...
Not really. My father was very good mechanically. He wasn't really interested in electronics, but he was always taking cars to pieces and doing mechanical things, so I picked up on that from him. And then I was quite involved with construction sets, a thing called Meccano, which I'm sure you're familiar with, and used to build all kinds of machines out of Meccano, but that was probably partly because, as I said, we didn't have any electricity, so.
Sure. And you said you were building crystal sets. Any other electrical or electronic devices?
You know, there was quite a lot of war surplus stuff on the market, so we used to be able to get these sort of microphone headset combinations which didn't require any power, so I would string those across the house and across the way to my friends, so we had some communication that way.
Fascinating.
And those didn't require batteries, so that was okay.
When was the first time you saw an electronic circuit? Oh, probably in the crystal set, probably.
It was in the crystal set. The crystal set was a pre-packaged one with a little cat's whisker. You had to sort of twiddle the whisker onto the germanium crystal to make it work. But then I read about a radio in a flashlight or a torch, as we say in England, in Practical Wireless, I think it was. And this used a transistor, which I'd never heard of. And when I went down to the local electronics store, the guy there had never heard of it. he was willing to sell me, an HL 2 or a KT66, but an OC71, never heard of it. So I used to devour the electronics magazines, and but never did get to build a radio in a flashlight.
Did you ever get your OC71?
I did. In fact, I think I donated some to the museum.
You did?
I did.
Absolutely right.
Yes. Little black glass encapsulated devices. And if you scratch the black paint off, you got a photo cell.
OCP71.
Exactly.
I remember that device.
Yes. Yes.
And so you went to school in Harrogate, and from there you went on to Cambridge University, I believe?
No, I went to public school in Shropshire, a place called Wrekin College.
Yes.
And that was from 1955 to 1960.
Okay.
I went through the O-level, A-level, S-level, procedure at the time. And there I did have a physics teacher called Mr. Frost, who was very inspirational, and he and I just sort of hit it off in terms of the way we thought, or the way he taught worked for me anyway. And so and that's when I really got to be interested in physics. There wasn't really any electronics curriculum there. It was physics, chemistry, math, the standard sort of natural sciences program.
And you took A-levels, presumably?
Took A-levels.
Those 3 subjects?
Those 3 subjects, chemistry, maths and physics, and then S-levels in the same topics, and then sat the Cambridge entrance exams and the Oxford exams, and went to Birmingham and a few other places in case it didn't all work out.
And you started at Cambridge then, I
Yes.
guess, in what year?
1960.
1960.
Right.
And you studied
this was natural.
physics?
Well, yes, ideally I would have liked to have gone straight into electrical engineering, but for 2 reasons I didn't do that. One was I had an industrial scholarship from British Petroleum that was paying my way, and I thought I might even want to be a geologist. I mean, it was a genuine career possibility. So I did take geology classes. I went and did the natural sciences tripos for 2 years. Physics, geology, math, I can't remember the other subjects. And to do to get into electronics, you could go through the engineering school, but then you had to spend the first 2 years doing dams and sewer systems. Right. There was no electronics until the 3rd year. The other way to go was what I did, was through the physics curriculum and then switch to engineering for the last year. I see. And then you can jump right into electronics.
Why did you switch from physics to electronics? What was the...
I think, once I got to Schrodinger's equation and they didn't know where the damned electron was, it was only a probability of being somewhere. I lost interest.
I gave up Bessel functions.
Yeah, well, okay, same sort of thing. I'm just much more of a touchy-feely person than speculating about whether a black cat's in a black hole or not in a black hole, or whatever Schrodinger's thing was. And it just, I just like the practical hands-on aspect of electronics much better.
Did you, let's see, this was early 60s, did they have computers available for you at all
No,
at school?
not at all, no. Yeah. In fact, they only had one person in the engineering school who knew anything about transistors. I mean, it was a vacuum tube. They were still teaching vacuum tubes because they were somewhat behind the times. And honestly, the electronics, I mean, Cambridge was terrific for physics and natural sciences. For electronics, in hindsight, they were really very weak. We had a professor from Stanford whose name I should be able to remember because I think he invented the klystron. So we didn't get taught
Hansen?
basic.
Hansen?
No, it wasn't. No, it was an Eastern European name.
Okay.
We didn't really get a basic grounding in electrical engineering, but we did get all the klystron theory you could ever want, and it was like, it was sort of. I felt like I missed out on a lot of groundwork that I should have had because they were busy teaching subjects which they had an interest in for their postgraduate programs.
So it wasn't exactly a hands-on course that was going to make you very useful when you walked out of the door.
And funnily enough, many years later, I ran into the same professor from Stanford up in the Trinity Alps, having a birthday party with his family, and instantly recognized him.
Small world.
Yeah.
And so you graduated in 63.
Right.
And you chose to go where?
I chose to go to Ferranti because, frankly, they offered the most money. And a friend of mine was also graduated at the same time, and we both accepted jobs at Ferranti, so we shared an apartment in Edinburgh.
Mm-hmm.
And my first job was designing this range gate for a train following radar system for the TSR-2 nuclear strike bomber, I guess is what it was.
Mm-hmm. What skills did you have to acquire to do that?
Oh, just about everything, actually. You know, I was working for a fellow called Brian English, who was a very, very good engineer and taught me a lot. Mm-hmm. And so, you know, he helped me. And the first, you know, thing I was working on was basically an integrator. It was just a fairly high gain amplifier circuit with capacitor around it, and we'd create these ramps for the range gate for the radar system.
And transistorized?
Transistorized, yes, yes, yes. And they would, you know, the idea of the TSR-2 was it was terrain following, and it would fly at 200 feet off the ground at Mach 1 point something or other, all the way to Moscow. So they used to take the design engineers who designed this radar system over the Highlands of Scotland. So it really made you think about what you were doing. But we weren't going at Mach 1.2, we were just going into some fairly slow aircraft.
Were there any integrated circuits?
No.
No, okay.
No. It was all discrete. Yeah.
I was selling Fairchild products to Ferranti in Edinburgh in 66 and 67, and my biggest order was, I think, 1,000 burned-in 709s at $900 a piece.
That's a good price for a 709. That's a very good price.
Short supply in those days.
That's a very good price.
So this was all transistorized.
It was all transistorized.
Did you design the complete product?
No, I didn't. I mean, I designed this one little radar range gate thing, and then really the project was cancelled pretty much right after that.
Ah, okay.
So, you know, it was sad to see the project go, but that's the way it was. So then Ferranti made an effort to turn that division into a commercial enterprise, and Brian English, the fellow I just mentioned, came up with the idea of having an automated vehicle location system, which you could sell to things like police and ambulances to know where vehicles were. And of course, this was way, way before GPS. Mm-hmm. So they used the police radio to radio back to headquarters the position of the vehicle, but you had to manually say which sector of the city you were in by dialing little thumb wheel, mm-hmm. you know, switches. So you had one out of 99 positions with 2 thumb wheel switches. And as you move, as the police vehicle moved from one sector to the other, you dialed in a new number, and then it would show up on the big board. And it was, you know, potentially useful because the police used to complain they had no idea where their cars were.
At the pub, probably.
What?
At the pub.
At the pub, yeah, could well be. So that was the project I was working on when my roommate that I mentioned from Cambridge got married, so I had to move somewhere. Mm-hmm. And another friend of mine called Wadi Kata, also from Cambridge, had come out to Transitron
the
year before and was writing me these letters about how beautiful it was and how great the girls were, and I thought, okay, why not? Mm-hmm. So I interviewed with Tom Longo in London, and that was it.
Was there a particular skill set he was looking for at that time, or anybody who could speak transistor?
I think probably anybody who could speak transistor and had, reasonably good educational background.
Yeah,
I mean, it's. I don't even remember what questions he asked me at this point. I just remember sitting outside the room, hearing him interview somebody before me, and kind of getting a little nervous because he had this very low, rumbling kind of voice. And but obviously, it worked out.
Okay.
And of course, at that point in time, Transitron, got me the green card. The whole process was very easy. Mm-hmm. So I had the green card even before I left the UK.
And so you moved to Transitron in
1965.
1965.
Yes, fall of 65.
And Transitron was located in Massachusetts?
Wakefield,
Massachusetts.
Wakefield, Massachusetts.
Uh-huh.
You know, they made me this offer letter, and the notepaper had this incredible hand line drawing of this futuristic building stretching into the distance at the top of the right-hand side of the notepaper. So on the Sunday night before I was due to show up for work, I went down to Albion Street and walked up and down the street trying to find this building, and I couldn't find it. And I walked several times past this run-down old brick mill and eventually realized that was it.
And Transitron in those days were they still a very successful company, or were they in a decline at that point?
In my opinion, they're at that point in the decline, but they had been the number 2 semiconductor company after Texas Instruments throughout the late 50s and part of the early 60s. And when I was at Ferranti, we were buying PNP transistors from Transitron. They were the best available. But somehow the transition to integrated circuits, they had a hard time with that. Partly because I think, you know, when you're in an old mill and every time you walk down the floorboard you get these puffs of smoke, of dust coming out, it's very difficult to make a clean room.
For sure. And Tom Longo, was he running the whole company then?
He was running the company for the Bacala brothers. So the Bacala brothers were the owners of the company, but Tom was very much CEO.
We actually did an oral history of David Bacala just a month ago.
Oh, did you? Okay.
Yeah. I haven't seen the transcript yet, but I'm looking forward to it.
So he's still alive?
He's still alive. He went
Okay.
on to a second career as a sculptor.
Really? That's amazing.
Internationally renowned sculptor, if you can believe it. That's how he spent his Transitron earnings.
Okay.
Interesting character.
Yeah.
And what did you work on at Transitron?
TTL. I mean, basically, they were second sourcing Sylvania, who I think were the originators of TTL, and they had a number of TTL designs that they were second sourcing, but they also had a contract, I think, from the military to do a 16-bit RAM, which was at that point the biggest RAM that had ever been built.
Right.
And certainly I wasn't that active in the design details, but I was involved with that. And we were, the Rubylith was bigger than any table we had in the building, so it was spread out all over the floor and pieces were glued together to make this immense memory of 16 bits.
How many designers were working on the project, do you recall?
3 or 4. I think the lead was a guy called Manhar Shah.
S-H-A-H?
S-H-A-H, I think. But I was also involved with, TTL had a problem, and that is that when it switched, it took an enormous glitch out of the power supply. It had a very, big, I don't even remember how many milliamps it was now, but it was quite a big hit. And we were looking at, could we design something which would take less of a hit from the power supply? And so I got involved with doing a circuit simulation, which, SPICE didn't come out until 1973, so this was back in 65 and 6.
So a circuit simulation on a slide rule?
No, it wasn't. No, there was a fellow called Nat Sokol who had a company called Data Automation, and he advertised an ability to do circuit simulation with a program called SEPTA.
SEPTA?
SEPTA, which is different from Cadence's current Spectra, which is a whole different ballgame. So SEPTA, we would give him the net list, and he would come back with an IBM printout of these fanfold about this thick. It had every picosecond for every node. No visual, no vision, no GUI whatsoever. This huge stack, and you had to go through and plot out whatever node you wanted. And it was an interesting exercise, but
was it useful? Did it?
Well, it was useful in that it taught me something about how the simulators, what the simulators could do for you. I think what happened realistically was that Schottky TTL came out and solved some of the problems of the big power glitch. But also by that time I'd realized that Transitron was underpaying me, and they were somewhat in a decline, but most importantly, they were just taking advantage of people from Europe. It was a stupid policy because it took me a month to realize I was getting screwed and 2 months to find a decent job. And that happened to so many people.
Now, because a lot of people moved to the West Coast from Transitron for the same reason.
Exactly the same reason.
Did you work with any of the Corrigan or Lamont?
No, they didn't overlap with me. I don't think there were any of the people who like George Wells, I didn't know him. If you look
Okay.
at the time periods, because none of us stayed very long, so we didn't overlap very much because it was a very narrow window.
Okay. So you stayed at Transitron how long?
I think I probably went there in about September, and by May or June I was driving cross country to Fairchild.
Okay. No, not less than a year.
Less than a
So-
year, yes.
Okay.
Yes.
And it was all, well, I guess output switching is a linear problem, isn't it, as much as it is a digital problem. Did you do all digital work at Transitron?
I did. They'd bought a 709, and we looked at the 709 and tried to work out what it was all about. But I really didn't get that involved in analog circuits till I got to Fairchild. And Fairchild tried to recruit me into two different groups. One was an applications group under Maury Siegel, and the other was an R&D analog group under Marv Rudin. And I ended up picking the R&D group, and so that's where I reported to work.
And so you were in the building out in Palo Alto?
On Aristodero, right?
Aristodero.
Yes.
That
Yeah.
was probably bigger than the whole of Transitron, right? Just the R&D building?
The R&D building wasn't huge. It was a single-story building.
Okay.
It wasn't huge. I mean, Transitron had this big old mill. I don't know what they used with the rest of it, but it was actually quite a big facility.
Sure. And you came in to work for Marv Rudin with a particular assignment?
When the initial assignment I had, I worked actually for Garth Wilson, who reported to Marv Rudin. And then I think Marv reported to Gordon. My initial assignment was, they said, Weidler left on Friday, I showed up on Monday, the yield for the 709 was 1 die per wafer, could I fix it? So I spent some number of weeks sort of analyzing the 709, trying to figure out what was going on, and came to the conclusion that there was nothing wrong with the circuit. And it turned out the yield problem had to do with they'd switched DI water suppliers at the factory, and the new DI water they were using wasn't of the appropriate purity or something like that, so it was an entirely independent problem. So then I got assigned the future successor of the 709, which was defined by marketing as take every spec on the 709 and make it twice as good. It's a typical marketing approach to approach. And that was the MUA 725.
Ah, yes.
So that was a 3-stage amplifier, and it was. I worked on the initial version of that, got working silicon, but by then National had announced the 101. I looked at that, I thought we could do better or do some things differently, and proposed the 741. So Marv Rudin said, you'll never get that thing to production out of the R&D group. There was this sort of competitive barrier between the R&D group and Mountain View. Why don't you move to Mountain View, get that thing done, and we'll have George Erdy, who was my roommate, office mate, pick up the 725. So that's what happened. He completed the 725, did a very good job, probably better than I would have done, and I went to Mountain View and did the 741 down there.
That was unusually magnanimous.
Well, it was, yes. And,
taking away a competent designer.
I don't know actually why there was even an analog group in the R&D building, because in Mountain View, in what I would call the production building or the production facility, Weidler had been there, Darrell Lear, Jim Giles, there were a bunch of people there.
Right.
Designing linear circuits. Why was there a competitive group set up in the R&D department? And the only reason I can think of, and it would be easy to confirm it if I was to call Marv Rudin, was Marv had more of a systems background. He came from either North American Rockwell or TRW or somebody, and I think he understood and sold maybe Gordon Moore on the idea that there was a generation of circuits like multiplexers and A to D converters that the people in Mountain View didn't understand. They were just thinking in terms of the component level. But for whatever reason, there was a so-called advanced analog group created in the R&D department, and they did. They pulled off. The 722 was a D2A. But it always seemed a bit arbitrary to have two groups. But it was interesting because I, got to know Andy Grove, Andy Grove fairly well. Took that semiconductor device physics course, which you probably heard about.
People
Which maybe you
reduced
took
to
it.
tears.
Well, yes, it was started at 6 a.m, which was enough to drive you to tears in the first place.
Right.
And then Andy was a fairly tough taskmaster, as you all know.
Right.
So I took that, and then actually was a teaching assistant for it in subsequent years. So that was a worthwhile thing to do.
So you had good grounding in analog then after a year? How long
Yes,
did it
I
take
think.
you to until you felt comfortable with what you designed was going to work? As long as they made the process correctly, of course.
Yeah, I think pretty well. It's self-taught. I mean, the thing is, there weren't a lot of people who had the skill anyway, and so you didn't have to know very much to be the leader of the pack. I got to give Weidler credit for what he did, because he did what he did almost in a vacuum. I mean, there was nothing there. And Talbot, and I think Dave Talbot deserves as much credit for creating a 40 plus volt process. The ability to put down lateral PNPs, which, I guess had been invented by C.T. Lynn at Westinghouse, but that still, Weidler put the whole thing together from a circuit point of view. Talbot put the whole thing together from a process point of view. And it was an amazing tour de force. And that really set the stage for all the rest of us.
So you were able to look at what he had done,
analyze his layouts, look at how they structured vertical PNPs and pinch resistors and isolation resistors. There's a whole cadre of components that they developed between the two of them.
And the unique feature of the 741 over its predecessor, the 709, was the addition of this internal capacitor.
The internal capacitor, honestly, I drew a lot from the original LM101, which is different from the LM101A. They're two different. Weidler redesigned the 101, made it into the 101A. So the front end, some of the front end parts. He really pioneered the idea of a two-stage single pole compensation amplifier, and then the rest of us kind of, really made use of that concept. And then George Erde, of course, took the 725, went to PMI with Marv Rudin, and maybe I'm jumping ahead a little bit here, but and developed the Oppo 7, which was a three-stage internally compensated amplifier, which is a whole lot more difficult to do.
How difficult was it to bring up the 741? Was it fairly straightforward?
Once I was in Mountain View, they really had quite a good machine, better than many subsequent companies. So once you'd done the design, it would go into the production group, and 3 or 4 weeks later, you get 100 pieces back from 10 different runs. So you had a lot of parts to characterize, and I would say it went relatively smoothly.
Were you working alone? Did you have a particular process engineer that you think made a difference?
Yes, well, I was working, I think, a guy called Samuel Water, who was the fellow that felt that we could put the capacitors down and make them reliable, and he did some experiments to show that that could be done. Because there was always the concern that the oxide defect density could be so high that we'd never get the capacitors to yield in production. So I will give him credit for working on the process end of things.
That's an important culmination in analog through the years, hasn't it?
It has.
Engineer and designer working together.
Right.
You mentioned Talbot and Weidler.
Dave Talbot and Weidler.
Are there other teams like that you can think of in the industry?
Well, I think the BiFET process that came out of National certainly revolutionized some of the FET kind of amplifiers. That was at a later date. And jumping ahead a little bit to the analog device Intersil days, that was a good combination, because analog devices had some design expertise, and we had the process expertise and the IC design expertise. We'll come to that maybe when we get to that point.
Okay, interesting sidetrack there. So after the 741 at Fairchild, that was a single op amp. You did a dual version.
Dual version of it, and by that time, Jack Gifford had left to form AMD with Jim Giles, Larry Stenger, Frank Bodie. It seemed like everybody was going somewhere to form a company, and I thought, well, why am I getting, And then I got the offer from Intersil, He went over and interviewed with Jean Hennet, and decided that was a good choice for me. I talked to Andy Grove about going to Intel, and I just wasn't interested in the digital side. But I asked him how much stock he would give me if I went to Intel, and he told me a number, and it was the same amount that they'd offered me at Intersil. Now, with hindsight, I would have done better with the Intel stock.
That's for sure.
But anyway, who knows what would have happened?
Sure. You were waxing fairly nostalgic about Fairchild at the Fairchild at 50 talk that you gave about the changing of the guard and what a difference it made to the company. Have you had any other thoughts about what was going on at Fairchild at that time? And why everybody was leaving to form their own companies?
It's difficult. I thought about that because when I was at Fairchild, we still felt like we were the kind of the king of the heap. I mean, there was nobody really close to competing with us on the analog side. So why did people start leaving? I think it was just maybe the frustration that Noyce and people felt that they were all being controlled from the East Coast by Sherman Fairchild. Maybe that filtered down. Maybe it was the fact that they weren't giving stock options and everybody else was offering options, and it seemed like, well, why not? But there was nothing really wrong with it. I mean, there was nothing. I had no complaints. But there was a fellow running the analog group at the time when I left called Len Ornick. I don't know whether you've come across his name.
Know the name.
And he made a half-hearted attempt to persuade me to stay at Fairchild, and then a week later he was gone to ITT in Florida. So everybody was jumping ship.
Interesting times. Were there other competitors appearing on the horizon in the analog business in those days? Obviously National. With anything coming out of TI or Motorola of note?
No, probably Radiation in Florida had a dielectrically isolated process. It was producing some nice looking op amps because they had PNPs, decent PNPs as well as NPNs. Motorola had, I think, second source the 741 at some point. I don't remember historically quite when. And I hope I have my facts correct here. I think they used a 100 orientation of silicon, and it didn't lend itself to building a 44-volt process. They were having some reliability problems, and we could look at their part and see the problem. And you could tell that it was 100 material, not 111.
Sure.
And, so we didn't tell them about that.
Point that out to her. How about in Europe? The consumer business must have had demands for analog parts in Europe. Philips probably? Or?
Yes, but I see at Fairchild anyway, the consumer products and the linear group, and then there's a consumer group. Right. So there were people doing circuits for circuits, Zenith and Dave Bingham and people, Larry Blazer. There was a whole nother group which were doing true consumer products for TVs, radios, and so on. And I think Philips probably had products in that marketplace, but we didn't see any competitive op amps for the industrial marketplace out of Philips.
So in '69, I guess it was then, that you talked to Intercell. Who did you interview with at Intercell, and what was their strategy at the time?
Intercell was primarily a matched low noise bipolar transistor FET company. John Hennet loved FETs, FET. That was his love. So I was the first analog IC designer. They had a contract from NASA to build a low power comparator. So that was my first project. So that basically probably paid my salary for the first year. So it didn't cost John anything to bring somebody over from Fairchild. And I worked for John Hall, who was sort of a thin film expert. And we did that product for NASA. And then we did a custom circuit for Canon camera, which was really an interesting project. So the first two circuits I worked on at Intercell were custom products. And I went to Japan and worked with the people at Canon for a while. So
you stayed in Japan while you were doing the work?
Not just for, no more than about 3 weeks at a time.
Okay.
But it was still an interesting experience for a young kid suddenly to find himself in. Because I was always a photographer, so I loved being around a camera company.
Okay. And what was the product you were designing for Canon?
It was electronic shutter. The problem in the single lens reflex camera is that you're measuring the light when the mirror's down. The mirror goes up, and the source of light to drive the shutter, if you have an electronic shutter, goes away. So you have to memorize what the light was before the mirror goes up, and then you've got to do a computation for the exposure based on film speed, aperture, and I'm missing something anyway. I can't think straight. So that circuit, I had to take the log of three things, do a computation, take the anti-log, and then derive a shutter duration. And it was it was fun. I mean, it was an interesting project. I did the whole thing with about 30 transistors, which today you'd throw 500,000 transistors and a big CPU at it, but in those days it was different.
Interesting, you mentioned log and anti-log. I believe that was something that you enjoyed.
Later on, I did
other
those.
Circuits with them.
I did
that
those
was your
later on.
first introduction to that kind of problem?
Yes, there was a paper by a guy I think called Peterson who showed that a good silicon transistor had a log characteristic which was damn near perfect over about 12 decades. It was amazing. So that's where the log anti-log interest came from. And then you see, we led right on into after that. Our biggest customer for the low noise FETs and the low noise transistors and so on was Analog Devices.
So
that started a relationship.
They were making modules?
They were making modules.
Right.
And we went to Analog Devices, talked about what their needs were, talked to them about their products, and had a pretty good relationship with Analog Devices in the early 70s. And so what they decided to do was form a relationship with Ingersoll. They hired a design engineer called Hank Krabbe out of Zeltex in Concord. And he worked in my office. We shared an office together. So my role was to teach him integrated circuit design. His role was to interface between the design engineers in Massachusetts and us. And we agreed to do 7 or 8 or 10 custom unique circuits, new circuits, based on market requirements which Analog defined. And then Hank Krabbe had experience at module design, so he knew some techniques I didn't know about, like feed-forward amplifiers and things. And my role was to turn them all into ICs. And that's what we did. And then we jointly marketed the products under different part numbers. So we went independently to the marketplace with different part numbers, but we shared the fruits of the labor, so to speak. And that was the beginning of Analog Devices' IC business, where products we designed at Ingersoll that they sold.
Were you the only analog designer at the time?
I hired a guy from Fairchild called Bill O'Neill, and he'd worked on the 733 at Fairchild, so he and I were the only analog designers. And then Hank Krabbe was, the guy from Zeltex that worked for Analog Devices. He was a fast study. I mean, he picked up very quickly.
And you were reporting to Jean Henny?
I was reporting at that point still to John Hall, I think.
John Hall.
John Hall, yes.
Okay.
Yes.
So was Henny very involved on a day-to-day basis?
John Hall?
No, Jean Henny.
Oh, not at the IC design level. Okay. He wasn't really interested in circuit design as much as he was in device design. I mean, he would have his head in a microscope looking at a new FET topology and measuring the characteristics of an FET, but he didn't really get involved in the IC design that much.
Had he started Eurosil at this time?
No.
That came later.
He had got a contract from Omega through his Swiss contacts to build a watch chip. And they did that. So in parallel with the analog effort and the discrete effort, there was a watch circuit effort going on at Ingersoll. Okay. And I mean, there's a funny story, because the very, very first prototype watch, we shipped the chips off to Omega, and they brought the product back in the form of this. This is like the big announcement. This is the first watch in the world. And they went off to lunch, and it was on Jean Henne's desk. And when they came back from lunch, it had gone. So someone had taken it. And they announced over the intercom system, no questions asked, the company is in dire jeopardy. If this watch gets stolen, please put it back. It reappeared.
Interesting. And so what else did you do at Intersil that expanded your analog horizons?
I did an FET amplifier, and the original one we did with analog devices, we didn't know how to match the FETs that well at that point, so we took two of the matched FETs that we would as discretes and bonded them into a chip which was the rest of the amplifier circuit. So that the joint venture chip circuit was really a little hybrid. And then I went ahead after that and did a truly monolithic one, which became actually a pretty good seller. And then the log anti-log amplifiers, and at some point, by now we're about 1973, I'd had this ambition to go sailing, so I took off for a year's leave of absence and went sailing.
Where did you go?
Mexico, Marquesas, Tahiti, Hawaii.
Your own boat?
Yeah.
Uh-huh.
Yeah.
Did you build any special electronic gear to take along with you?
You know, actually I did. I needed a chronometer. And because Intersil had these watch chips, they'd also came up with a stopwatch chip. And so I took this stopwatch chip and turned it into a chronometer so I could do the celestial navigation. But other than that, we had nothing. We had no radio. So we set off across the South Pacific for 3,000 miles.
You and your wife? Was
yes.
She?
Well, actually, a girlfriend at that point in time.
Uh-huh.
Yes. Took off across yes. There's a much longer backstory there that probably shouldn't be part of this discussion. But
any particular adventures on the way that?
Oh, we had all kinds of adventures along the way. Yeah. You know, I think one of the things in sailing is you don't say that you're going to go from here to Tahiti. You say, I'm going to go from here to San Diego, and then you get to San Diego and say, okay, I'm going from here to Cabo, and then you say, I go from Cabo to Acapulco. So we just took it one stage at a time, and then made the big jump across the Pacific for, that was a 30-day passage.
Wow.
So that was a good adventure.
And this was a year you were gone?
Basically a year. When I started the trip, Intersil stock was at 22. And this was fall of 1973.
Okay.
And I got down to Mexico and I called Jack Gifford and said, how's it doing? And he said, oh, stock's at $9, but he couldn't possibly go any lower. Absolutely impossible. I got to Tahiti and up in the Wall Street Journal, and it was 1 3/8.
Oh my goodness.
So then I kind of knew the trip was over. So
what was going on at Intersil at this time? Do you recall?
I mean, there was a recession. I mean, there were hard
Big
times.
one. Sure.
But Intersil had been through a series of managers between, Jean Hennet stepped aside, Marshall Cox, Jim Riley was there, Marshall Cox was there, Bob Freund was there. It was kind of a sad situation because, the company had some good technology.
Right.
But the management, in my opinion, left quite a bit to be desired. And I think that was the root of the problem.
Yeah.
On the digital side, by then they got into digital circuits. At one point they had 60% of the prom market. They had this called AIM technology, which was a shorting reverse bias diodes.
Bill Sievers was working on that. Bill Sievers worked on that.
Yeah. Yes. And somehow they lost it. And then they jumped into the PDP-8, CMOS version of the PDP-8, and really that was a product too late. I mean, it was, piggybacking on an old instruction set didn't make a lot of sense.
So in Tahiti you discovered you no longer had the wealth you thought you had.
Exactly. So I called Marshall Cox and said, what do you got? And he said, what we'd really like you to do is go to Europe and set up an applications group in Europe for a year. And that kind of appealed to me because it was a chance to go back home and live in England and see what I thought of it, and yet always have the freedom to come back to the US. So that's what I did. I went to the Reading office, and that's not in that level.
And what year would that have been?
And that would be 1974, fall of 74. And I stayed there until mid-76.
Okay.
So almost 2 years.
And what was the focus of the office? Was it analog?
It was sales. No, it was a sales office.
Oh, sales.
So I was basically applications engineer for the whole product line, including the CMOS version of the PDP-8 and the whole
Okay.
works. And then I had to hire applications engineers in the different countries.
Right.
And we gave a series of seminars. That was the big thing, was presenting the product line through seminars organized typically by the reps.
Sure. Had you hired people very much before?
Not really, no.
Yeah,
no.
so that was your
no.
first experience of
But well,
that.
other than Bill O'Neill, I'm trying to think who else I hired before leaving
Uh-huh.
Intersil. Probably not, right.
Interesting learning experience.
So yes. And then eventually I hired my own replacement in the UK,
Okay.
a fellow called Dave Watson, who I'm still, very friendly with and in touch with. And
So you kind of made too much of a mess of it then, huh?
no, exactly. No, he's right. He was out here only a couple of weeks ago for a barbecue, and
Okay, good.
so
75 you returned, then
so in '76 I returned,
76, okay.
and Jack Gifford by then. When I left, I was actually working for Roger Smullen,
Yes.
and then Jack Gifford took over the analog group. So when I returned from the UK, I was working for Jack Gifford. And I forgot, lost the train of thought now. What we
So you returned to Intersil in 76
Oh,
to work
that's
with
right,
Jack, and what was the role you were coming
And Jack
back to say?
basically said, I'd like you to run the engineering group. So
Okay.
he gave me, responsibility for not only the analog engineering group, but also the whole of engineering. And I don't think it was a VP position initially, but it became a VP position.
Okay. So you had digital,
Digital and analog.
logic and memory.
Yes, yes.
Quite a
There wasn't
span.
much, honestly, much memory at that point.
Right.
And then the other big change at that point was that Ori Hoke became involved. I don't know whether you've come across
Did
Ori
they
Hoke's
merge
name.
with AMS?
Yes, Ori Hoke was hired or became CEO of AMS, and he used to be CEO of Litton Industries. And I think he just wanted to have a change from LA, a change from big defense companies, get involved with a small company. So AMS made him CEO of that company, and then we merged with AMS. And Ori basically was a very mature, very sophisticated manager, and he, I think, was from day one had in mind polishing the company up and selling it. So I give him credit for lifting the stock from 1 3/8 or where it was down here, and we sold the company to GE in
Right.
19, I think roughly 1980.
Okay.
1981, I'd have to find that exact date. But Ori did a good job of managing the company compared certainly with the predecessors that had been there. And then when GE bought the company, Ori recommended that Jack take over as president, and that's what they did.
And what was the company predominantly at that point? Digital, analog, mixed still?
Both of the above, yes, mixed. In our view, analog made all the money and the digital people spent it all, which is part of the origins of Maxim. And there's an exact parallel going on at National.
Yes.
The National had a very profitable analog division,
Right.
a number of missteps in the digital area, and I think that was the genesis of Linear.
Yeah. Yeah. Very similar story.
Yeah. Of course, having GE step into Intersil was initially appeared to be okay, but that didn't work out. It just was.
What other analog circuits that you mentioned? I believe a band gap reference you designed at Intersil. That must have been an important stepping stone to other products later.
It wasn't actually really. When I got back from Europe and was managing the group, it was by then about 75 engineers, and it was a fairly flat structure, so it was pretty much full-time job managing the group.
Yeah.
Now there were a lot of successful products that came out of the group. The 7106 digital voltmeter chip became very successful, and there's a whole range of industrial timers and counters and display products that came out of the group. So we continued to proliferate the products, a huge range of analog switches that were designed by a guy called Dick Willincoln, who lived up in Wairika. He was a very good, productive engineer. So just managing the group, frankly, was a full-time job. Even though when Jack told me that he wanted me to take over the engineering group, he said, "David, it'll only take you 10 minutes a week. Don't worry about it." And somehow I fell for it.
No, not a detail man.
So,
How did you go about choosing the products, David? Did you obviously had important customer interface? Certainly the relationship with Analog Devices must have been very useful in terms of understanding what kind of products to build. And how did you continue that after Analog Devices was no longer there?
in the early days, certainly we could look at the module products and say, okay, this is one we can bite off and make it into an IC, and basically it'll wipe out the module product. Like a log amplifier. You know, there are a number of log amplifiers from Analog Devices, Burr Brown. And Analog were smart enough to realize that was going to happen. So that's why they created the interface with us to learn IC design, and eventually they went off and started Nova Devices, which was a semiconductor facility in Massachusetts. And then Hank Krabbe, who was the fellow that I shared an office with, we taught IC design. He then went to Limerick and Ireland and became general manager of Analog Devices Ireland.
Yes.
And did a very good job. I mean, they have a scholarship in his name, and he died some time ago, but they, you know, Hank Krabbe was a first-rate manager and a first-rate engineer. But I think the product definition came from really just listening to customers. And I think we put a lot more value on the applications engineers to look at how the customer was using the existing products, and then how could we sort of bring in more and more, rather than just having a marketing guy say, "Oh yeah, you know, take this op amp and make all the specs twice as good."
Right.
And there were actually two competing groups in a way at Ingersoll. One run by Maurice Siegel, who was, I mentioned before, and he had an industrial products group, and they did the timers, the counters. There were about 15 or 20 quite successful, what we called industrial products. And then Jack had the analog products, which are the amplifiers, references, regulators. And that's really how the product line got created. And we followed that same concept at Maxim of relying heavily on applications engineers to define the products.
Did you have the applications engineers in the factory or in the field, or
both?
Both.
Both.
Okay.
Yeah, both.
How do you go about
Both.
hiring a good applications engineer? What criteria did you look for?
Anybody that seems to understand what the customer needs.
Okay.
I mean, the most successful applications engineer I've ever met was a fellow called Charlie Allen that we hired at Ingersoll just before we started Maxim, and then as soon as I could get into Maxim, I got him over there, and he just has a brain like a sponge. I mean, he could just absorb so much information. He could walk into a customer and just understand the whole picture. And those are the guys you're looking for.
Absolutely.
And Dave Watson, who I hired to replace me in England when I left there, is the same way. He understood what the customer needed, and he understood the whole system. So he could pull in peripheral bits and pieces and put them on the chip. And we can, you know, jump ahead to the Maxim days when the RS-232 product was exactly that kind of thing.
Did you still have to work very closely with process people at that point, or were the processes pretty much defined and this was told this is what you had to work with? You had to come up with any new structures, or?
I think at Ingersoll we were still, no, there was quite a lot of process development going on. We had, you know, the CMOS process. The CMOS process really made a big difference to the analog business at Ingersoll. Okay. And we had Dave Bingham, who was a very creative design engineer, said anything you can do in bipolar, I can do better in CMOS, period. So we developed CMOS processes to suit partly his needs, to design the products he was designing.
And his claim was true?
Yes, absolutely, yes. Yeah, he did. I mean, he and Lee Evans, another person from the Ingersoll days who came with us to Maxim, were designing chopper amplifiers, designing DVM chips, designing a whole range of products in CMOS, which hitherto might have been done in bipolar. So when we started Maxim, it was 100% CMOS, basically.
Interesting. And what was the genesis of Maxim? You said that you were getting a little frustrated with the GE bureaucracy?
Yeah, yes, I think, first of all, the idea of having a purely analog company had nothing to do with GE. It had to do with the experience we'd had with Intersil being partly digital, spending all the money, and partly analog, making all the money. But then when GE came along, Jack Welch said all the right things. He said, we're not going to touch you, we're going to let you do exactly what you want to do. And we had dinner with him in the city one night, and he was saying, don't worry, Dave, it's going to be fine. Do exactly what you want to do. You can create stock option programs, you know, do this, do that, do the next. But a month later, 2 months later, the guys with the green eye shades moved in. and we got allocated to, well, allocated is not the correct word, we got put in a division, the light bulb division, which probably isn't the most creative division in GE, right. Working for a guy called Jim Baker. And Jack and Jim Baker just did not hit it off. And you know, they felt like we should be on the same salary structure as their people in Poughkeepsie. Mm-hmm. And they didn't understand that, you know, house prices are 3 times as much as blah, blah, blah. So the relationship started to fall apart. Mm-hmm. And I was really only a partial witness to this, because Jack was trying to interface with the GE people to get decent compensation for the employees, and it wasn't working out. And eventually he had a big blow up, and they fired him, basically. I mean, he just was so adamant that he wanted these things, and they said, you're not going to have them. Out of here. And that was the December of '82, I think.
Okay. And
so Jack went off and did his tennis and farming and various things. And
that's right, he had an apple ranch or
he had a pear ranch and a tomato ranch at different times. Right. Then sometime around March of '83, I got a call from Jack saying, why don't we start a company? I said, sure, let's do it. So he and I and Fred Beck got together in a coffee bar in Woodside and decided to give it a shot.
Was that was not a difficult decision for you then?
Not at all.
Okay.
No.
By now you were married by now? Any kids?
Yes. Yes. But still, I don't know. I just don't sit. I don't know that I really fit into huge companies.
What was the process of getting Maxim up and running? I guess the 3 of you each shared different pieces of the puzzle.
Yes, I wrote the original business plan. I mean, Jack was, you know, we'd get together and talk about what the business plan should say, and I was the only person with a computer. I had an Apple II at that point with a little Epson MX80 printer. So I go home and draft a thing, and then we bring it and we critique it, and then I go back home and draft it again. And so we did a VisiCalc spreadsheet, and we did 4 pages of write-up about what we were going to do, and that became the business plan.
I think, remember, it was posted in the lobby of
Maxim. It is, yes. I've got a copy here if you want, but anyway. Okay. So it was, that was it. And then we set about raising the money, and Jack had, because of his AMD days, I think, he had contacts in the VC arena that I certainly didn't have. Mm-hmm. So we floated the business plan to 5 or 6 venture capitalists. And I mean, Jack had this really good intuitive understanding. He said, as soon as you get guys that look negative, back away, never get a no. Because if you get a no from somebody, they're all a bunch of sheep that all say no. So you work around, you know, the groups and groups until you get someone that's really biting. And once one guy bites, they all want in because they're a bunch of lemmings. Right. And he was right.
Do you remember who the first bite was from?
I think it was from Kippagopian at Brentwood Securities.
Not familiar with him.
I remember going down there, and Kip had a big sort of partner's desk, and there's a stack of business plans, most of them very thick business plans all on one side. And our little 4-page thing was sitting on his desk, and he said, at least I've read yours. I haven't read all these, this is way too much. And I was basically, here are the people, this is what we're going to do.
Okay.
And he agreed to invest.
Mm-hmm.
And then
how much money did the first round come in at? Do you recall?
It was a commitment for $10 million total. Mm-hmm. $5 million initially, and then the other 5 predicated upon announcing 14 or 15 circuits.
Okay.
So that we had a fairly aggressive plan to get 14 to 15 circuits out within the first roughly 18 months.
Mm-hmm. That's a lot of circuits.
We hired a lot of people.
Okay.
I mean, no, my job was just to hire as many people as I could, as many consultants as I could, as many layout people as I could, as fast as I could. Because,
where did you find them?
you know, we did
a good hunting ground, but
well, we had a lot of people at Intersil that were equally unhappy. So the initial team was all from Intersil except one fellow called Sam Ochi, who was from Teledyne.
okay.
And he was our sort of token non-Intersil person, so that Intersil wouldn't sue us based on the fact that we'd stolen all their
100%.
people. And they sued us anyway, so,
Of course.
of course.
How did you go about? Well, these were known entities, so it makes it a
Exactly.
lot easier, doesn't it?
It's a lot easier, and the initial plan was to do second source circuits because we needed the immediate revenue. We couldn't afford to have the time for people to design them into their equipment,
Right.
and then their equipment to get accepted by in the marketplace.
Right.
So we picked 14 or 15 of the most popular circuits that were out there and did them.
What tools did you have? Spice? Anything beyond that?
There were versions of Spice. We had Calma. We rented time on Calma's machines for doing the layouts.
Mm-hmm.
But since most of the circuits had already been designed once, we were second sourcing them for the initial round of products. You know, it didn't need a lot of simulation because we knew exactly what we were doing. We knew what the process was. It was just a question of getting them done.
Did you have your own fab?
No,
Okay.
no. So we were using foundries.
Mm-hmm. Local foundries, or?
Yes, primarily local foundries, and some pretty shaky operations when I think about it. I mean, if ever the company was vulnerable, it was in those early days when some of the foundries were distinctly shaky. There's one I can think of that was in Scotts Valley, where the fellow running the foundry hadn't paid his air conditioning contractor, so he came into the building one Monday morning and there was a huge hole in the fab area because the guy had taken a crane and just pulled his air conditioning system right off the roof. Yeah, those were shaky days.
Yeah, interesting. Was there one or two particular foundries that really came through for you and made the difference?
You know, I wasn't directly involved with the foundries per se. I mean, all three of them came through in their own way in the end, but it made us. We had a fellow called Robert Shear who was responsible for qualifying the incoming wafers. So we did a very, very analytical job on the incoming wafers to make sure that they were processed correctly. And then we burned in every product. So we had a massive investment in burn-in racks and ovens because we said we were doing it because that gave us better reliability, and it did. So our big sales pitch was to the customer was, you know, we can prove because we've analyzed it that Intersil and Analog Devices and these other people have a failure rate of X and we have a failure rate which is down here. But we did it partly by burning in every part.
Most of these were CMOS
Yes.
parts?
Yes.
Was CMOS a stable process by then?
Well, we were using metal gate CMOS, which was a pretty old-fashioned process. So it was certainly stable, but if the foundry misprocessed it, it wasn't stable. So the irony is that GE sued us for stealing their secrets. And the only secret they could identify was the CMOS process that had been around for about 12 years.
Which they probably... Interesting. So what were those first couple of years like? Was there times of particular concern and worry about whether you were going to pull this thing off? Or was it fairly safe?
No, it went fairly smoothly. I was under a lot of pressure because, of course, Fred Becker was in marketing saying, give me some products, I need the products, you know, I can't do anything till you give me the products. So that, and the market when we first started the company was fairly hot for product. By the time we had got the products out, there was a sort of mini recession going on. And there was a certain amount of, oh, if only we'd had the product 6 months ago, we could have sold, you know, X, Y, Z.
Sounds like a standard salesman's.
You say, well, right, yes. But then when we did have the product, we actually started by going to market in Europe because there was sufficient demand for these products that if we'd gone worldwide, we wouldn't have been able to satisfy the demand. So we announced the first products in Germany and France.
Right.
And then once we'd ramped up production to satisfy that need, then we announced the products in the US.
That's unusual.
So the first purchase order was from Germany.
Yeah. Did you have any challenges with getting qualified at some of those big German companies? I remember Siemens was always a very tough nut to crack. And
Yes. We certainly did, because I remember going to Siemens personally and making a presentation about the reliability of the products. And you just had to convince them with the facts.
Right.
We showed them the burn-in data, we showed them the reliability data, we showed them the statistics, and we had a believable story.
That experience you had running the applications group in England must have come in very
Would
useful.
Would help.
Those early days.
Yes, you learn very quickly in Germany. If you're not there 10 minutes before the meeting, you're late.
Right. It's like deliveries in Japan. They open the gates for 3 hours, and if you're not there, the order's cancelled.
Right.
When did you start looking at proprietary products at Maxim?
Almost immediately. I mean, we knew that we needed proprietary products to build up the image of the company. So Dave Bingham in particular was thinking about proprietary products, and by then we had Charlie Allen on board. And I think the first proprietary product was a Max 610, I think was the part number. And it basically took the line voltage in directly through a capacitor and pumped out 5 volts DC. So, and it was an interesting product, and it actually worked most of the time. It wasn't one of our most reliable products, probably. But we got a lot of customer interest because it was huge, because here's a tiny little chip, and all you need to do is add a capacitor in series with the AC, and you get 5 volts out.
Yeah.
And we had interest from people, in microwave ovens, for example, for the display, and interest from people doing power meters who needed, smart power meters. But it wasn't one of the better selling products. But then the RS-232 product is the one that really hit the nail on the head in terms of proprietary products.
How did you come up with that idea?
That was really Charlie Allen's idea of realizing that all the RS-232 products, they basically typically only had a 5 volt power supply on the board, and they had to generate plus or minus 12 to do the RS-232. And he went to Dave Bingham, and Dave Bingham said, I think I could design that, but doing a charge pump that goes both ways in CMOS is kind of tricky, because you have a latch-up problem potentially. So you really have to do a pretty weird-looking layout to prevent minority charge injection that can cause latch-up. So this thing had what we call the racetrack around it, which was a big sort of peripheral thing that sucked up all the floating electrons. But it was very successful. And it's not a product that we would normally have thought of doing, because RS-232 was not considered to be an analog product. I mean, really, it typically fitted on a digital board. It's not something we'd ever notice.
Yeah,
if we just look at what's surrounding an op amp or an A-to-D converter, or you wouldn't see it.
Yeah. Did that generate a whole family of similar kinds of products?
Yes. Yes, a whole series of different numbers of inputs and outputs, and different combinations. And then the second proprietary product was, again, Charlie Allen's definition of a microprocessor supervisory circuit, so that you could watch what the microprocessor was doing, and if it got into some sort of an endless loop, you could detect that and issue reset signals. Okay. And that became very successful as well. And so those are the two which started generating a lot of revenue.
Did you look at particular market areas and say, we want to focus on this, that, or the other? Or these sound like two just sort of bright ideas.
They were. The early days were bright ideas.
Right.
Later on, we became a lot more organized, if you like, where all the applications engineers had a charter to bring in so many new product ideas every quarter. And then we'd have this sort of massive session where we tried to sift through them and pick the winners. But the early ideas were really just bright people coming up with bright ideas.
And you were VP of engineering
at
this time, and so you had design.
I had design applications and layout.
Okay.
Right. And originally I had test engineering, and then we realized that didn't make any sense. Test engineering needed to be in manufacturing.
Right. Okay. So, oh, I see your sailing sabbatical.
Did I show it? Did I show it in there or not? I may not have.
Yes, you had it in Maxim, but we were talking about it in the when I
I did it again.
Sill line.
I did it again.
Oh, we did it again.
Oh yes. Oh yes.
Okay.
So,
You didn't learn the first time.
No, I enjoyed it so much the first time. I wanted to do a second time.
So tell me about number 2 sailing sabbatical. Where do you go this time?
I've always had this sort of horror of, you know, you retire at age 65 and the next year you get a notice from the doctor that says, sorry. So I've always had this idea of sort of packing it in as you, not packing it in, that's not a correct term, putting in periods of doing what I want to do.
Good for you.
To the extent that, you know, I could do it without jeopardizing my career too much.
Mm-hmm.
So in 1990, I decided to take another leave of absence and go sailing. And by then, it didn't make a lot of sense to have one total engineering operation under one person, because we started thinking in terms of market segments and having each market segment have its own entity of marketing, design, even manufacturing to some extent. So I went off for a year sailing and then came back and did another of these application stints, setting up worldwide applications engineering.
Mm-hmm.
Because by then we got you know, totally autonomous divisions doing within the company.
Right.
So the
Applications
engineering
to bring this all together.
engineering was split up between the divisions.
Mm-hmm.
There were about 6 or 8 different segments.
How big was the company by this point? Do you remember?
It was between $50 and $100 million, I think.
Okay.
Because by the time I retired, it was about $500 million.
Okay.
Yeah.
And who were the real competition then? Linear technology, presumably?
Linear technology,
analog
devices, to a lesser extent, Burr Brown,
yes.
Texas Instruments, National.
Uh-huh.
Those were the real competitors.
Any one or the other that you'd sort of meet more frequently, do you think?
In the bipolar arena and the standard, like the op-amps, regulators, references, linear technology was the biggest competitor. In more of the CMOS subsystem products, it was probably TI. I mean, they had a pretty good organization at turning around products fast, and certainly we got ourselves competing on a couple of custom circuits against TI, and they were pretty effective.
Okay. Now, didn't Maxim purchase Dallas Semiconductor
Yes.
at some point? Were you involved in that process at all?
No, I wasn't actually. I may have been even partially retired, because I remember Jack telling me about it at a cocktail party, and I don't think I was even working full time at that point.
Okay.
The first acquisition that I was involved with was the Tektronix fab.
Yes.
So we purchased the Tektronix semiconductor operation, which turned out to be a very good deal, because they had a semiconductor operation which was first class, but they had almost no volume because it's not that kind of company.
Right.
And they needed it for a very, very limited number of small circuits and hybrids and specialty products. So we came up with a deal with Tektronix where we would run the facility and we continue to provide these specialty products for them.
Mm-hmm.
And
wasn't Barry Gilbert at
he wasn't.
Tektronix?
But he was by then he was with Analog Devices.
Moved on to analog. Okay.
Yeah. So he was. Yeah, he was with Analog.
Uh-huh. And so that was a manufacturing arrangement.
That was a manufacturing arrangement. We had design up there as well, though.
I see.
So we inherited their design team. We inherited their CAD team. So I would spend a day a week up there.
So they'd report to you?
Yes.
Yeah.
So I would spend a day a week up there interfacing with the design team up there.
Mm-hmm. Did they focus on a particular area?
You know, at this moment, I can't think of the product line that they were working on, actually, which is.
Yeah. What did you most enjoy about your job at Maxim? You had 2 quite different jobs in a way. The engineering job, which is very structured. Applications engineering is a lot less structured than you.
Yeah, I think the engineering job probably because I mean the company was successful. I mean the stock was sort of almost doubling every year, and everybody was pretty enthusiastic.
Right.
So I mean the whole time was actually good. I have to say I have no complaints.
Mm-hmm.
It was fun. It was fun.
How did you and Jack work together? Did he just say, "Hey, go do this"? Was he involved on a day-to-day basis?
Oh, Jack was involved in every microcosm of everything. So he would, you know, I kept thinking each time the company would grow that he would have to sort of run out of steam, and in terms of his ability to control every detail, and he didn't.
Uh-huh.
So he was involved intimately. He would run the company by a series of meetings. So he'd come into work in the morning and there'd be a meeting. And it was on any topic, and there were some routine meetings, you know, how many products we're going to get out this quarter, you know, manufacturing starts, marketing reports. But anytime he sensed something was not quite right, he'd call a meeting. And then he just wade into it. And he had an amazing ability to get down and find the weakness in your argument or your presentation, which is, you know, a lot of the strength of the company was just his ability to control that level of detail.
Yeah. I had a couple of bosses like that, and they were the most successful ones. For sure.
Yeah, well, yes. I think it takes
Also
attention
the
to
most painful
detail.
ones.
It takes attention to detail.
Sure.
And he wasn't always kind in his assessment of your you know, what you were doing. But he and I, you know, honestly, I had known him since the early days of Fairchild, because he was running the linear marketing group.
Right.
And we're going back in history now, but you know, Mike Markler was in that group. Mike Scott was in that group that became briefly CEO of Apple. Len Brown was in that group. Jerry Ziss, who was marketing for PMI and Analog for a number of years. And so I'd known Jack from way back when. And we used to go on seminar tours together at Ingersoll where we were presenting the products. And you know, we were personal friends as well. So
any big differences in terms of how the company should be run, or between you and Jack?
In the early days of Maxim, yes, we used to have some discussions about, do you really have to be that hard on everybody all the time? And Fred Beck and I would sort of compare notes at the end of the day and say, you know, we're going to lose our people if he keeps on doing that. So one or other of us would take turns to try to moderate him.
But successful
nonetheless. And you know, I think it takes that kind of personality actually. And
it does.
Not unduly different from, you know, Swanson's a hard driving guy.
Linear, I work for Rodney Smith.
Charlie Spork was a hard driving guy. I mean, that's maybe what it takes.
Yeah. So you ran the applications group for quite a few years, 6 or 7 years, I guess.
And I tried to retire a couple of times, and then I would have this plan to go on, you know, 2 days a week, and then I show up to work Monday morning. I wouldn't get out till Friday. So I think it was Len Sherman that said, "I'm the only guy he's met who'd failed retirement 3 times." So eventually, what happened was I said, "Okay, I'm going to retire. I really am this time." And my wife said, "Okay, I'm going to book enough travel to keep us completely busy for the next 6 months, so you can't go back to work." And that's what she did.
And so 1988, you retired, and I think the company...
98.
1998.
98, the end of 98, yes.
And the company was how big then?
$500 million.
Okay.
I actually had to look that up because I didn't remember it, but yes, it was $500 million. So now they're about 2.5 billion, I think. And other than sailing and traveling, you were a board member or a consultant for a company for a while? I still am, actually, yes. For Genia, this is...
Genia.
Yeah,
okay.
yeah.
What does Genia do?
Genia, there was a fellow in my applications group called Roger Chen who was an MIT graduate, bright engineer, and then he left Maxim and went back to college and went to UC Santa Cruz to study microbiology and DNA and so on under Dima, who was one of the early people in the Human Genome Project. And then he thought, well, I could I've got these two skills. I understand the biology and I understand the electronics. I think we could develop a chip which would do genome sequencing. And I ran into him in Radio Shack about 6 years ago, and he said, "Come to my house. I wanted to show what I'm doing." He shows me, because it was in his garage. All the best Silicon Valley companies have to start in the garage. And he had his little refrigerator there, and he had a little circuit board here with an op amp and some other stuff on it. And he felt like he could design a circuit that would do DNA sequencing.
How does it work? What's the basis of it? How does that work? What's the basis of it?
There are certain biological, let's call them things. They actually bear a resemblance to the tuberculosis virus. But anyway, there are certain things which you can insert into a cell which have a very specific orifice size, and that's how maybe tuberculosis invades a cell. So given that you have an orifice in a cell of a very specific size, if you put a single strand of DNA through that orifice, the bases are all very slightly different. The four bases C, A, T, G are very slightly different in magnitude, and they will constrict that cell differently. So if you flow a current through that cell, you can modulate the current. You put a voltage across the cell, you can modulate the current as a function of what's in the cell. And this is nothing particularly new, but I think what Roger understood was that with IC technology, you could create a circuit that would measure 100 or 1,000 or 1,000,000 of these at one time. So that's what Genia is doing. They developed
create a chip and you physically place the cells on the chip?
There are ways to there's an array of measurement cells, and then you create what's called a lipid bilayer, which is like a simulation of a cell. So it's a bilayer of a lipid substance, and then you can actually take alpha hemolysine, which will invade or can be inserted into the lipid bilayer. And now you have the lipid bilayer, you've got this thing inserted in it which has a hole which is about 1.4 nanometers across. And now you're in a position, if you can make DNA flow into that hole, you can measure the base that's in the hole at any given time by the extent to which the current is modulated. But the trick is you're measuring currents down, you're trying to distinguish currents down in the femtoamp level. So it isn't a trivial analog exercise to do this fast.
It's an analog exercise.
It's an analog exercise, exactly. It's a very analog exercise. So Roger developed a prototype for this and got some funding. And we did the first chip was 264 array. And now the chip we're working on now is 128,000 array. And the next one will be 1 million or 10 million, we don't know which. And it's a completely different business model to Maxim, where in Maxim's case we were doing something everybody knew how to do, we just had to do it better. Right. In this case it's a breakthrough, nobody's done it before. And it's not entirely assured that we'll get there. I mean, it's a high, we believe it's a high probability. But it's been fun. It's been interesting to stay in touch with
keep
the
those gray cells
technology
moving.
and stay in touch with the technology. And my role, it really is on the intellectual property side, because one of my roles at Maxim was to make sure that we were patenting things as we went along. So I'm watching out for their patent portfolio.
Interesting.
But they just sold the company to Roche for $350 million. So from starting in a garage 5 years ago.
Another great success story from a garage.
Well, yes, exactly, right. Right, so I go there, a couple of times a week when I'm in town.
Where are they located?
They're on the corner of Matilda and Ellis,
Okay,
basically.
so you
down.
come over the hill.
Yes, I come over the hill.
Or
yes,
down the hill.
yes, down the hill, right.
So outside of that, David, you've been a photographer a long time.
Yes.
Still,
I had an uncle when I was young who was a photographer and sailor. So I learned my best, most compelling interest in life outside of work from him.
Mm.
And so I've been doing photography and sailing since I was 8 years old, 10 years old.
Photography has changed a lot in that time.
It has changed a lot. Yes, it has changed a lot.
Right.
Yeah. I mean, the only thing that hasn't changed is can you see the photograph, or can you? Whether you take it with film or digital doesn't really make any difference.
Uh-huh. Do you do much post-processing?
Quite a bit. I do quite a bit. I mean, nothing extreme. If you can see that I worked on a photograph, I've failed. Mm-hmm. Now there are some people that will go to extremes and make something that doesn't look like reality, and that's fine. It's just not my style. Mm-hmm. Mm-hmm. So we go on we're going to a photographic group going to Santorini end of next week.
Santorini is in
Greece.
Greece. That would be a wonderful trip.
And I did one in Tuscany earlier this year. So it's just nice to be with a bunch of other photographers. We have the same interest.
Sure.
No.
Any other things you've got set for the future that you want to accomplish?
Oh, I got my bucket list, but it involves mainly
traveling
probably, just see a few parts of the world I haven't seen yet before I get too decrepit to see them.
If you were what advice would you give a young person entering technology these days? I won't say integrated circuits.
Yeah.
It's so vast now. I mean, when we started in semiconductors, you could start, you know what a diode was, and you could build on that.
Right,
I don't know where you'd start today.
I'm not sure I do either. I mean, I think the only advice you can give is follow your interest, see where your passion leads you, and make something useful. I mean, that's one of the satisfying things about Genia is if we can pull this off, the goal is a $50 genome, complete human genome. You know, whereas the first time they did it, it cost, I think, $20 billion and involved 40 academic institutions. And we'd like to be able to do it in an hour or two and do it for $50. Now, we're not there yet. But that gives you the ability to go into a doctor's office and get a pretty complete diagnosis. And then if you, so there are, cancer treatments possibility and that kind of thing. So I would just advise somebody to do what, go where your passion takes you. I noticed another thing, the end of Mike Markula's oral history. He talked about advice from Bob Noyce, I think, who says, create value, don't just shuffle money around. And that's good advice. I like that advice. 'Cause my economic model for countries is very simplistic. A successful country is one which is creating value by manufacturing stuff. And I'm a little concerned, the US, if all the manufacturing goes to China and all that happens here is we shuffle money around.
UK even more.
UK even more. And that creates a disparity of wealth, especially in the UK, where you go to London and there's Lamborghinis everywhere, and you go to Liverpool and it's pretty sad. Yeah. So I'm not quite sure where that train of thought was taking me, except the idea of, creating microprocessors out of sand is adding value. Creating cherry jam out of cherries is creating value.
Sure.
But shuffling money from one lawyer to another lawyer isn't creating value.
Anything else you'd like to go on the record here with? About your career? Or
I'll probably wake up tonight and think of all the things that I missed out.
Well, I really appreciate you spending time with us. It's been fascinating hearing your career.
Thank you. I appreciate the opportunity.
Okay.